Alright, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have the model 1250 Marantz, as promised last week. If you didn't see the tuner video last week, go back and watch it some other time when you have the time and inclination to do that. But today we're going to focus on this one, and I've just been testing it out, and all the controls are actually really nicely working. There's no scratchiness in any of these sliders. The switches seem to be behaving. The switches as well here. Volume control. Everything seems okay. So hopefully this is going to be an easy, quick turnaround on this one. The owner of this is the owner of this, so he brought them together as a pair. He wanted them both serviced. So we're going to go through this and do this once. Full recap on this one. I think it's going to probably be necessary if it hasn't been touched before. And I'm pleased the switches are okay. Probably the relay will need to get worked over, but aside from that, I think we're doing pretty good. So I apologize for the crappy audio on the video. I'm using a backup camera. My main camera died on me. Well, it didn't die. It just developed a little whoopsie. I might fix it and get it back online. But I did order a new camera, so we'll see how that works. I don't know. See how that would. Out of all these cameras, I'll pick the best one. So not much else to say about this other than, let's see here, at idle we're doing about 40 watts. It's just pretty normal for an amplifier of this caliber. So let's get the lid off and have a look inside. Alright, screws are out. It's unplugged. Let's pull the lid off. Nice black painted inside lid with corrosion. Heavy corrosion around those foam strips. And inside we have a capacitor the size of a pop can, and we have this massive transformer. It's as big as my head. This thing's huge. And then we got two amplifiers, and then all of our low level signals are under a shield here, a shielded box, and then it looks like power supply right here. Yeah, it's a nice unit to work on. It's all original. So we'll get started on this. Yeah, it's a very nice design. The back panel's even shielded. You can see back here to keep hum down on all your inputs and outputs. Power supply, our power mains is unprotected here, so we've got to be careful of this. This is a shock hazard here, especially since it's so close to the heat sinking. And it's all exposed too. Not a fan of that. Fusing looks like, I don't know what these fuses. Let's look at this one. Can't read it. It's supposed to be 8 amps. Where's the marking on this? 8 amps, okay. 1.5. 1.5, it's all correct. This one is 1.5 as well. All our fusing is correct. Okay, so I'll get some shields off here. Get this shield off at least. You see, we all got the original Marantz silicon in the back here on the power devices. They're all original. So we've got a very nice design here. It's very modular. It looks like everything's got connectors. The power amplifiers have connectors down the bottom, I can see. The tone sliders, they all have connectors. This is a tone board. This is our filter board, the loudness, filters, and it's got like a connector here. So it looks very modular. It can just disconnect things and unplug them and service them. And then when it comes time to assembly, just click it all back together. Power supply fuse board here. Underneath the fuse board there is a protect circuit with the relay. So I'll have to remove all that, service that relay. This power supply board I'm not too sure about. I don't see any connectors underneath, so it might be hardwired. But yeah, got some unique capacitors here, 1000 microfarads, 70 volts, and they're axial. So we might have to order some caps, unless we can substitute in some radial caps. But very nice design, very built for service. That's what I like about this. So this will be actually instead of a chore, it will be a pleasure to work on. Yeah, I don't know if somebody's playing with me here or what, but these screws are welded in place, it seems. It's like they put them on with an impact driver, and I'm trying to get them out without stripping them. There, that one went. I don't see any Loctite or anything on them. Just looks like a normal thread. It's an M4. But if I do strip them, I can replace them. Like this one's all stripped. Might have to get the pliers out or do something here. This one here I'm going to try. Well, that one's loose already. I loosened that one. But oh, this one's stripped. That's right. I turned this all day long. It's not coming out. It's stripped. So somebody must have used an impact to drive these screws home, and it ruined the threads on some of them. Alright, a lot of fighting, and I finally got them all out. And yeah, it doesn't look like it's been off in a while compared to the dust. And really not much under here. There's a board here. I think this might be a tone board or a phono amplifier. Really not much under here. Access for the cap. Oh, and our rectifier diodes. Pretty much it. And some little road map here. What wire is what? No access for the power supply from under here. Okay. And everything seems to be accessed from the top. So, except for this board. So next up, I'll just pull off the faceplate and knobs and get started with what I do. Here's a look at the front panel. It's a little dirty, so I'll get this cleaned up. Yeah, cleaned up nice. So we have one filter can for the capacitor, but we have 3 terminals, so this has 2 capacitors inside this can. One's for the positive, one's for the negative. So replacing this capacitor be near impossible unless we wired up separate caps, and I don't know if we have room for separate caps. You'd have to modify the mounting somehow, but we'll test this and we'll see. It's probably just fine the way it is, leave it alone, but if we did have to replace it, we'd have a problem on our hands. Okay, the relay's out. Let's test its contact resistance. This hooked up. Alright, here we go. This is one side. Got 1 ohm, 800, 2 ohms, 6 ohms, 3 ohms, 8, 12, 2. I think you get the idea. So it's all over the place and it's high. Let's try the other side. 77, 90, this side's a lot better. 40, 50, 55, yeah. So I'll do a clean on this, and this relay will get cleaned up and it'll be 100%. Alright, here's a look at the power board complete. Finished recapping. I did not replace these caps, these 4. Pulled these out and tested them. They're perfectly fine. They test good with value and ESR, even though they have like a 1976 date code on them. I'm going to run with these. They are expensive to replace. They're about $10 or $12 a piece in my currency, so yeah, they could replace them, but there's really no point because they're doing their job. Same with these ones. I do have these in stock, but I elected to just leave them. Otherwise, all the other caps are gone, and it really opens up board space to allow air ventilation. I've mentioned this before. When you put brand new caps in, they're a lot smaller than the originals, and it opens up all the airspace around the components and allows better air ventilation, cooler operation. So this board is done. Still haven't. I'm going to remove these 2 transistors. This is that transparent grease they use. It's a heat sink compound, but it's like a grease. It's a clear transparent grease, and it probably could be redone. It's probably time. They have the collector tab on both these transistors cut. So when you flip it over, this is our collector. It's done through the screw. So we got to make sure that is tight, and then have star washers on both sides to bite in and grip and make the electrical contact. So I'm going to remove these two transistors, re-grease them, test them for HFE too while I got them out, why not? And then clean the back of the board, and then this board can go back in. It's all done. I checked these resistors, they're all fine, especially the power ones. You don't know, a power resistor gets heat soaked, it could change its value. Alright, here's a look at the, pulled the transistor off, and underneath there's basically nothing here. It's pretty much dry. And if you look at this, this is dry too. That's that grease they use. I don't know. Sansui uses this grease too. It's a transparent grease. Early 70s they were using it. They seemed like it was a good idea at the time. But this stuff is just completely new. But this isn't a good example. This transistor I don't think is working too hard. I don't think it's getting too hot. It's probably adequate with the way it was. But I'm going to re-grease all this and just make sure it's going to stay cool. One change I am going to make here is these bleed resistors. These are 2.2k ohm resistors across what I think is about a 65 volt rails. So we have two resistors. So each resistor is going to draw about 2 watts just to do nothing. When you have the thing powered on, it's just creating heat for no reason. Yeah, when you shut it off, it bleeds the cap down. But do we need a 2.2? No, we don't. So I'm going to upsize this resistor to a 6.8k, 1 watt, and that'll reduce the consumption from about 4 watts to probably closer to 1 watt when it's in idle, in operation. So there's a little bit of energy savings there. Yeah, this is just creating unnecessary heat. That's all that's doing. 4 watts is actually a lot of heat if you think about it. If you contain it in an area, you can get a lot of heat buildup with 4 watts. Alright, so let's have a look at the phono stage here. This is some of what I'm looking at here. Marantz, for whatever reason, in their wisdom, wanted to use tantalum caps in all these positions. There's actually 1, 2, 3, 4 tantalum caps in each amplifier, and they're used for coupling. Now I can understand why back in 1970s tantalum caps were superior to electrolytics. Probably still are today, but my biggest problem with tantalum caps is they tend to fail. After 50 years they can fail. They're a solid electrolyte. They don't have an electrolyte, they have a solid pellet, and that makes them stable. Makes them temperature stable, gives them more benefits when it comes to regarding audio frequencies, higher frequencies. They tend to handle higher frequencies better than electrolytics, and they're more flat over their range and stable. Like I said, I'm going to get rid of these just for the simple reason is they're 50 years old and we don't know if we can trust them any longer. Now, for example, in this position they used a 1 microfarad coupling capacitor, tantalum, and I'm replacing it with a film. This film capacitor is actually superior to this tantalum in probably all aspects. This 1 microfarad is better in ESR, it's better in high frequency stability. Noise, who knows with noise, they're probably both the same on noise, but that's why I'm going with film. And a lot of these other ones I'm going to go with film too. Like this here is a 4.7 microfarad here, but if you look on the board, they left the track layout for 16 millimeter lead space, so they were intending on putting a film cap here, but they decided against it and put this tantalum. So I'm going to put a film cap in that position. I do have film caps 4.7, but they're huge mongrels and they don't have the lead spacing that I need, so I can't use these. But I have ordered some. They're smaller versions of the film cap yet. Power supply. They have a 47 microfarad 63 volt in this position. I'm going to upsize that to 100 microfarad. And for this 10 microfarad 50 volt, I'm going to use a solid polymer. This actually is a filter cap for the differential pair supply stage. Now we have another problem here, these weird resistors. Marantz specified, this is resistors in the feedback loop, and they specified 866k ohms for these two resistors, and these resistors are now wildly out of tolerance. They don't measure anywhere close to 866k. So what I'm going to replace these two, I'm just going to make up resistors out of a 470 and a 9. Sorry, this is a 470. One of these is a 4, yeah. This one's a 470 and this is a 390k, and together they come out to about 862 or so, 864. But I can hand pick resistors and make it bang on 866. So I'm going to do that, replace these two resistors. These ones I pulled up to test and they're fine. All the other ones test fine. Yeah, so that's my plans for the phono stage. There's also a 33 microfarad tantalum here, 10 volts. I can replace that with a audio grade cap. It's probably not the best choice. It'd probably be good to go with another tantalum in this position, just for its lowest ESR properties. And but I think an audio grade cap will do fine here as well. I don't think you'll notice the difference if I put an audio grade cap here versus a tantalum. I don't think anybody would hear the difference, to tell you the truth. And these two down here are 4.7s. I'm going to replace those with film as well. So these four 4.7s will get film caps. These two will get audio grade. Alright, here's a look at the phono board completed. I had to order these 4.7 microfarad film caps special for this project because I didn't have any of these. And I'm kind of liking it. There was 4 tantalum caps here, 4.7s. And surprisingly enough, one of them had failed. And when I pulled it out, I tested it, it was bad. The other 3 were good. But everything's done on this card. Just need to clean it up now. And it can go back in. I just want to show you the 4 that I took out. These 4 here. These 4 here. I don't know which one it was, but I'll show you what a good one looks like on the meter, and I'll show you a bad one. Alright, here's one of the good ones. And we got right on 4.7 microfarad, 6.6 ohms ESR. That's pretty typical for a tantalum cap. And then here's another one. This one's not as good. This one's the same value. Actually, yeah, same value, but the ESR is now 11 ohms, which is no good. And one more check here. Here's another good one. And then this one is bad. I'll show you the difference. So, microfarads is up to 6.8. ESR is at 160 ohms. That cap has failed. And it was directly in the signal path for one of the channels on the phono stage. So, yeah, you're not going to get balanced sound with this cap in place. So that's why I elected to go with these film caps. And here's one of the film caps. 4.2 microfarad and less than 1 ohm ESR. Now if I go up in frequency, you see how the characteristics of the film cap stay pretty stable. The microfarads don't change. The ESR goes down, right, as I go up in test frequency. Go up to 10 kilohertz and it goes to 54 milliohms. I think this is what you want in your audio path. You want a cap that's going to be stable in this and stable in this as well. This is an audio grade Elna cap, Silmec 2, and it's a 4.7 microfarad, 25 volts. Let's see how it compares with the others. So here's our value, 14 ohms ESR. It's actually pretty good for a 4.7. Let's go up in frequency, and then you see how it changes. The microfarads start dropping as we go up in frequency, and the ESR goes down. And then 1 kilohertz, 2 kilohertz, 4 kilohertz, 8, and 10. So we're down to 3.9 microfarads from 4.6. So it's quite a range over the frequency range. Over the frequency response, there's going to be quite a range in capacitance. So like I said, I think these film caps will do really well in this position. These are coupling caps. These ones I'm not, yeah, I think these are coupling caps as well. Never really looked at the circuit too carefully. But better than a dead tantalum, and film, in my opinion, are better than the wet electrolytic. So this is the tone amp board, and this is the schematic for it. We have 14 tantalum capacitors on here, not one electrolytic, not one film. So I'm going to go through and replace all these caps, because I have a sneaky feeling that 1 or 2 or 5 of these are dead or dying, like I found one on the other board. Now, so what do you do in a situation like this where the manufacturer uses all tantalum caps and you want to replace them? What kind of caps can you just replace them with? You can't just blanket replace them with all electrolytics. This circuit just won't work properly, and it'll sound like crap. Well, you got to figure out where the tantalum is located. Tantalums are very good capacitors for audio use. They have very good characteristics for passing audio signals. They have good characteristics as far as temperature, coefficients, but they do have some drawbacks. They have voltage limitations. You can't reverse voltage polarity of these, and you can't over voltage these capacitors, otherwise they tend to short circuit, and that's what we're trying to avoid, right? But you can replace some of these with film caps, and you can replace some of these with electrolytics, and you can replace some of these with solid polymers. And let's look at the schematic to see how you would determine which capacitor you would use. Any capacitor that's in the signal path, you have the choice of either electrolytic or film capacitor. You can't use solid polymer caps in the signal path. They're not intended for coupling caps. If you read the data sheets on solid polymer capacitors, they tell you right out that you shouldn't use any solid polymer cap for any coupling purposes or any timing purposes. So that rules out some caps here. So for example, we have coupling caps here on the input. These two. These are tantalums right now. We can put film capacitors here. And then if we follow the circuit through, we have another coupling capacitor here, but it's 47 microfarad, which you're not going to put a 47 microfarad film cap in its place. So here you could put a electrolytic. Then on the output we also have coupling caps. These two here are couplers, so these can be film caps, and I can use one of these 4.7s right in line here. Here is another coupling cap, 2.2, so we can use a film cap in this position. And I think that's it. Yes. So we also have some other caps. We have 1, 2, 3, 4, 5, 6, 7, 8. We got 14 total, so we got 6 more caps outstanding here. So we have this one here. This is 100 microfarad at 3 volts. And right here and here. What they're doing with these two caps is they're filtering. This here is the negative supply rail, and they're filtering this junction to the supply rail with this cap. There's a 470 ohm resistor to provide the correct amount of current, but they want to effectively AC couple this transistor junction to this rail. So that's why they're using a 100 microfarad cap here. And what it's doing is it's providing a very low impedance path for AC to this rail. So you can use solid polymer here. We'll put SP solid polymer there and there. And also here we have a 33 microfarad at 10 volts. And these are doing the same thing, but they're going to ground. So this is reference to ground. This black line here is ground. And there's a 39K resistor to provide the DC path. And then they're effectively shunting all the AC to ground with this 33 microfarad. So we could use a solid polymer here, solid polymer there, and we have one more spot. This one here, CE07, CE08, a 33 microfarad, 10 volts. Now what they're doing here is they have a capacitor in series with a resistor, 16K. So we don't need the extreme low ESR of solid polymer. We could just put a regular electrolytic in this position because it's in series with a 16K resistor. Same on this side. So we could just use electrolytic. So there's our plans. We have 4 solid polymers, 1, 2, 4, 8 film caps, and 2 electrolytics. And that will cover off all the capacitor replacements on this board. Now you're more than welcome to replace all of these with tantalums if you want. They're expensive. You might find them difficult to find in their radial leaded form. But every time I do searches for tantalum caps, I always get the surface mount ones, which means you would have to mount them on the back side of the board and observe your polarity. Would I go that way on this? No, I'd probably go this way. Okay, I just spotted a mistake on this schematic here. Where is it again? CE13, CE14. You can see it clearly says 47 at 35 volts. But if you look on the board, CE13, I don't know if you can see that, that's a 4.7 in there. And CE14 is also a 4.7, so you got to be aware of these traps. So I adjusted my list accordingly. So this is what caps I'll be placing where. So these are 4.7 film, put those here. Let's see here, we got 33 solid polymer here and here. We got 2.2 microfarad here, 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 and here. 100 microfarad solid polymer here and here. And we have these regular 33 microfarad regular caps go in these 2 positions. And then I'm going to change this up. I'm not putting the film cap at these positions. I'm going to put, this is a 10 microfarad bipolar audio grade cap here and here. So that's what it's going to look like when I'm done. This cap here is the coupling between this amplifier, and it goes out to the tone controls, and then the tone controls come back, feeds back, and goes through this coupling cap. So there's 2 coupling caps between the amplifier and the tone controls. This doesn't have to be 4.7. It can be 10. It could be 22. You could pretty much put anything in there and it will work. It's just coupling audio. So I'm going to get busy on this and get started, and we'll. Okay, finished. That's what it looks like. And this is what I found. So all these caps are fine. These are 2.2 microfarad, these 4. This one's probably the best of the bunch. These ones are degrading, high ESR, so these ones are on the way out. They got 1 foot out the door already. So it was a good thing these got these out. These ones were fine. You could still run with these, but these were all coupling caps. Now, would you hear the difference between a good cap and one of these? Probably not. The difference right now is very subtle, and it's just starting its decline on these 3, and so they're all gone. They're replaced. So I'm just going to show one of these potentiometers, these sliders. These actually were in good shape when I tested them, but we're going to open them up and clean them because they do collect dirt inside, and give it a freshening up inside. I'll show you what I do with these. They're pretty easy to get open, that's why I'm doing it. Otherwise, not a big fan of just spraying things in the front and just leaving it, because all you're doing is redistributing the dirt around inside. So peel back all the tangs. No need to mark this because it only goes together one way. So we got 6 tangs here. Let's pull these out. Okay. And carefully pull this apart. And leave the slider in. And this is where we're going to focus our effort. So you get your resistive track here on the bottom, and then you have a silver plated slide 0 ohm trace here on top. And I'm just going to use cotton swab and some 401B. Sorry. Okay. So this, actually I can do this track first. Just give it a gentle wipe. We're just removing any dust, and you can see it's not that bad actually. And there's no lubricant on the resistive track. There's only lubricant on this, and it is quite black. You see all the filth on there. Just give it a few passes. Get it nice and clean. Okay, that's all the cleaning we need to do. I'm using this Veda grease DFG 213, and I'm only applying this to the slider track. So I'm going to use a clean stick. Just take the smallest amount and just distribute it on this. Oh, I got too much. Just going to distribute this around here. Now I didn't put anything on the resistive track because the 401B leaves behind an oily residue, and that's all the lubrication that's going to need. This part, all we do is we clean the fingers. This finger's bent down for some reason. Bend it up a little. Just clean the finger off. Any trash on here from the other. Let me clean this better. Okay. Don't remove the slider from the body, otherwise there will be a ball bearing that'll fly out. See, there's a ball bearing on this side that catches in these windows. If you want to clean this all out and relubricate it, that's your prerogative, but I don't think it's necessary. It's moving pretty smooth. And put it back together. The single finger goes on the metal track, the double fingers goes on the resistive track. So it only goes one way. Just hold it together, give it a workout. Distribute that grease, take it off, have a look. Everything looks good. Okay, close it up. Solder that back in, and we'll move on to the next one. Okay, you're probably going to run into problems getting this amplifier module, especially on this left side, in and out. You get four screws, 2 on each side, and the module just lifts out. But there's 2 connectors buried down in the bowels of the wiring here that your fingers aren't skinny enough or long enough to get to down there to reach. So what I do is you just remove 5 screws, 2 in the back, 1 here, 2 here, loosen these 3, and this whole side frame comes off. You just have to pull it out, and then you get lots of room. You can put your amp in, or take your amp out, put your amp in, that back in, and then just put the screws back. And then everything's nice and tidy. And then I'll do the same for this side. I don't know, this side's easier. We don't have a big cluster of wires underneath. We don't have the relay and the fuse panel and everything blocking access. This side's a little easier. And if you struggle with this side, just take these 5 screws out and do the same thing. Now these power amp modules, I took them apart. I repasted all of the heatsink. They had some transparent grease on here. Some of these transistors had pretty much nothing on them, and some of them were fine, but they're all pasted up properly now. I think I changed 4 caps on this and repasted these 2 transistors, the drivers, and I checked these little transistors. They don't have the fuzzy legs like I saw on a previous Marantz. And tested the resistors. They're all within tolerance. I resoldered the back of the board, cleaned it. Pretty much nothing else to do on this other than just put it back in, and we'll run with it. Tested the HFE and all these transistors. There was 1 or 2 that were down in value, but for the most part they were okay. This one's a lot easier to connect, so we can just do this now. Put these connectors on. I know you can't see what I'm doing, but there's lots of room to get your hand in here, and then you can just drop it into place. And I'll secure that down. What's it sitting on? I think. Pull this out again. Yeah, we're just sitting on the wires here. That's what's hitting the bottom. Okay. One thing to always do, always, is check for continuity between the heatsink and the transistors. I think we're good. So I can screw that module down, and then I'm just about done. I'm got to assemble all the components in the front here, the tone circuits, the phono stage, put it all back together, and then we're ready for testing. So this one actually is fairly easy to work on compared to some. It's very modular. It all comes apart. Like I said, it comes apart. It's all in modules, and it's easy to put back together, easy to service. And yeah, it's gonna be a nice project. Just about done putting this thing back together, and really starting to appreciate the build quality of this thing, how nice it is to work on. It's so modular, everything just plugs back together again. And yeah, this is actually a beast amplifier in just a regular package. That is huge, that transformer. And then it has these amplifiers. I didn't realize this thing is 125 watts a channel. And yeah, it's got tandem outputs, big massive heat sinks on each side, and it's powered by this brute transformer. It's incredible. I did check the cap. It is testing, this is a 14,000 microfarad at, I don't know what voltage it's at. Let me see here. 70 volts. And we're testing down around 12,000 microfarad for both sides, so this cap is good. There's really no need to replace a healthy cap like that. All I gotta do now is I have to ultrasonically clean these knobs, and then we put this all back together, and it'll be done. Alright, we're back together enough that I can plug this in and test it. I'm going to do the initial setup. We have power supplies here. We have, let's see, On pins 808, 809, 810 we should have plus 55 volts, and that's regulated with potentiometer R814. I don't know which one 814 is, top or bottom. And then we have on pins 814, 815, 816 we have negative 55 volts, and that's regulated by R815, one of those two pots. I'm going to figure out which one's which. So we set up the power supplies for plus minus 55 volts, and then we go and we set up our DC balance. This is our DC balance for the right channel, for the left. Once the DC balance is set, we can then adjust our bias, which is 10 millivolts. Now they say across pins J715, 716 on the power amplifier boards, those pins are buried underneath. But what Marantz has done is they've put some pins up top here for us, and it says test point. Oh, you know what? It's marked already, J716, 715. So those are the pins we connect to. And then same on this side, there is two pins down here in this bottom corner, top corner, that we connect our voltmeter to. So, with that out of the way, let's do our initial power up. And let's hit. Went up to 105 watts, down to 40 some. Relay click. And we are on. We are alive. Okay. So I'll let this, I'll do the adjustments. I won't show it on camera, but I'll let you know how that goes. This is the bias for the right channel. It was very close. It's 1 millivolt off. I'm just going to let this sit and idle for a while and let it warm up. The adjustments were pretty much bang on. Even the DC offset was on 0. The power supply on the other side, one side was high, so I adjusted it down to 55, and the other side was bang on. So pretty much bang on before I started. So I'm just going to have to monitor it now for any creep and adjust accordingly. So this is probably one of the first amplifiers I ran into that when you adjust the bias, as it warms up, the bias goes down in value, not up. This is probably the way that's configured. Now I'm just letting it warm up and giving it, see, it went down again. So I'm just going to let it warm up and hit its target of, I don't know if I should target. Yeah, I'll just keep monitoring this and let it do its thing. Adjustments are done. Let's fire this thing up and do our power test. Let's turn this thing on. Relay click. So I'm feeding a signal, but let's see here. Oh, see, I have no pre-main jumpers installed on the back, but we're still getting a signal through. So I don't know how they're doing that. But let's just turn this up until we get clipping. Kind of a. Okay, so this thing is supposed to be 125 watts a channel, so that would put us up quite a ways. I'm going to see if we can reach that here. Oh yeah, there it goes. Ooh, hang on. Let's try this now. There's our clipping. Let me adjust this down a little bit and this one up a little bit. We have a better look at. Okay, so there's our clipping. Before I start, I'm going to check a few things here. Hang on. Stand by. Okay, I'm back. So let's do this again. Okay, taking it up to clipping. Going on the left channel, which is the top trace. I'm going to turn this right to this point, I think. And we got 35.44 volts RMS. Start our timer. We've got nearly 500 watts going in. Alright, so we're down close to the 10-minute mark. Power consumption dropped a little bit from, well, it dropped a few watts, down to 467 or so. And that's after it warmed up. This thing's not really, let me turn this down. Turn off the fan. Okay, so what do we have here? We have about 52 degrees. This side's a little less, 47. I don't know why the right was a little different than the left. I think the levels weren't correct because I didn't have my sliders all in the neutral position. I think some of them were quite, can't really see here, but I think some of these weren't, the left channel were lower than the right, so that's why we had clipping on the right. So right up now, you get clipping on both equally, so that's what that was about. So let's switch to square waves. So there's a 1 kilohertz square wave, and I believe, let me see here. All my sliders are zeroed, tone defeat. There's tone defeat. See, without the tone defeat, it's a little bit. Here's the low filter, and then the high filter. And their loudness is pretty typical. Alright, so let's go down in frequency. 100 hertz. 90, 80, 70, 60, 50, 40, 30, 20. 20 hertz. It's actually doing pretty good for this old girl. 10 hertz. Not bad. It's not a DC amplifier, you got to remember that. So you're not going to get a good low-end performance like you would with a DC amplifier. Alright, let's go back up. Okay. 10 kilohertz. And we kind of lose it around here somewhere. That's 34, 35 kilohertz right here. It's actually doing pretty good for this old amp. Let's go through the controls. Tone defeat. We saw how that works. So they have bass, mid, and treble for each channel. So the left channel, bass cut, bass boost, mid cut, mid boost, treble cut, treble boost. Okay, that's all left. Right channel, bass boost, bass cut. Okay. Mid, boost, mid cut, treble boost, treble cut, treble boost. So they're all clean. I did treat these pots, and balance is working good too. I did treat them and relubricate them, so they're all working 100%. Just going through some of the other controls here. Switches look clean. Okay, tone defeat. Not bad. Turnovers. Everything looks good. Gotta say, it's all good. These are tape switches, so we don't. Everything's good. No complaints. Alright, pleased with that. So all I have to do now is put some covers on. Some covers are missing. And put the lid on, the bottom plate. And then I'll bring you back in and we'll talk about this a bit. Alright, so here's a look at the parts that went into this thing or pulled out of it. These are electrolytics. For the most part, these are all okay. I didn't find any failed caps in here. These two were on the power amplifier. I think they just stuffed these in because that's the best they had for them. If you look on the schematic, it specifies 100 microfarad at 3.15 volts, which tells me it's a tantalum cap. But they use these low noise caps in their place. They're not very good ESR, and they're old. So I replaced them with solid polymers, and that should be a lot better in that position. The rest of these, like I said, they're fine. 2 resistors out of tolerance, power amplifiers, replace those, and I replace these bleed resistors with a higher value to provide a little better efficiency on the amplifier's use. Tantalum caps are a different story. I found, I think it was 3 failed caps in this bunch, and they were all the 2.2 microfarad. The lower value ones seem to fail first. The higher value ones hold up better. But I'm thinking these all need to go. Every time you encounter an old vintage tantalum cap, I think you should take it out. Even though they test fine, I think you could replace them with something modern and get a better result, and more longevity, long life. Let's just say long life. So that's all that went into it. Alright, so that concludes this one. I really enjoyed working on this one. This one is easy peasy to work on. Nice modular design. Boards plug into each other. There's really, yeah, you can't mess it up. And it's nice. It was nice to work on. I enjoyed it. And it's a very nice build quality on these machines. So this one concludes the Marantz equipment that I have. I don't have any more Marantz after this. I do have, coming up next, I have a Kenwood power amplifier and then a JVC integrated amp. And then if my client feels better, he says he's sick right now. He was going to drop off a Sansui amp, but he got sick and he says hold off on that. So get better, James. Gonna get your Sansui going. So that concludes this. I'm gonna end it here. Not much else to say. Thanks for watching, and we'll talk to you in the next one.